we only have about 7 more class periods that I'm gonna teach, maybe 8. Okay, that's not a lot. We have 2 chapters to get through, but I have simplified them incredibly, okay, so that you just need to know the basics. And they're going to be combined into one test, probably about a 40-point test, those 2 chapters together. For that test, I will be giving you this final exam formula sheet so that you'll be able to see all the formulas you'll have for the exam. And I will point out the ones that relate to the 2 chapters we were working on. Okay, so that way you know where to go to find your formulas, you know how to use them, and that will help you prepare for the final as well. Okay, so we are.
Why did we get all one final?
2 hours, I think.
What?
2 hours?
What? Is it really 2 hours?
I think so.
Like, okay, but like, will the test actually take 2 hours?
The chemistry one could,
Guys, guess
but if you know what you're doing, it won't.
Wait, we need to know like the whole like electronegativity and stuff.
Water.
I don't think for the final you do, because it's midterm and then final. I'll give you a review packet.
These
I
are
cannot
but
remember
it has
that.
milk in this thing.
Nobody can.
Ice cream and water. Ew.
Okay,
Yeah, but still. Are you trying to know?
no, I'm not listening to your jibber jabber.
Everything and milkshakes are made from water. It's water and ice cream. Yeah.
Not of all the chemistry.
Neither is McDonald's, I hate to break it to you. Okay, so in this chapter, we are talking about solutions. Solutions are actually not new to us. We have learned about solutions, you just don't know it because we haven't really used the term solution a lot. Where did we hear the word solution before? Right now, where else? Gosh. Okay, so not just in single replacement, but anytime we predicted states of matter, remember that in chemical equations, we use the term solution. What is the state of matter for a solution? Aqueous, okay? So we have been working with solutions, it's just we haven't really defined what they are. So that's part of what we're going to do here. We're going to talk about a little bit of the terminology related to solutions, and then we're going to do some really basic math. And I promise you it is basic math. Okay, so review of mixtures, because a solution is a mixture. Mixtures come in 2 different types. One, and this was actually chapter 1 of the year, was called a heterogeneous mixture. And I don't have that in the slides. So this is one of the 2 types, heterogeneous. Does anyone remember what a heterogeneous mixture was? Think about the root there, hetero. What does hetero mean? Opposite. Kind of, it has to do different, okay? Different, opposite. So if a heterogeneous solution says different, what is probably different about it? Not elements, not compounds. It could be compounds. If I were to look at a heterogeneous mixture, how would I know it was heterogeneous? Thank you, Rosie, for answering that. You can see the different parts. Okay, so a heterogeneous mixture, you can see the parts. So things like chicken noodle soup, chili, okay? Yeah, grass, because you can see the individual blades, okay? So those are all heterogeneous mixtures. But that's not going to be the focus of this chapter. We are going to focus on the other type of mixture. Oh, definition of a mixture, just in case you don't remember. A mixture is a combination of 2 or more substances that do not combine chemically. So in other words, if you put 2 elements together, that is not a mixture. That is a chemical combination called a compound. Okay, but mixtures are physically able to be separated. So if you needed to get the beans back out of your chili, you could. Okay, so mixtures can be separated by some type of physical means, filtering, hand sorting, evaporation. You could get something back with. Okay, so this is the other type of mixture, homogeneous mixtures. What does the word homo mean? Same. So what do we know about a homogeneous mixture? Okay, which means if it's dissolved, it all looks like one thing. Okay, so it looks the same throughout. We call that uniform appearance. Okay, the uniform appearance and composition, meaning it looks the same. You can't see the individual parts. You will not see solid pieces and liquid pieces together. They will all mix to form the same state of matter. And in the case of something like Kool-Aid, we call that aqueous, okay, even though it looks like a liquid. So here's one example of a homogeneous solution. Kool-Aid powder dissolved in water makes Kool-Aid, which is a homogeneous mixture. Salt water is your other example. Homogeneous mixture is synonymous with solution, meaning when we say the word solution, we mean we're talking about a homogeneous mixture. And when we say homogeneous mixture, we are talking about a solution. Okay, so they are one and the same. All right. Within a solution, and this refers to any solution, there are different types of solutions, but any solution has two parts. Okay, so if you want the definition of solution, it's the same as the definition for homogeneous mixture because they're the same thing. You can just put solution equals homogeneous mixture if you'd like. So solutions can always be physically separated. They don't have to be chemically separated. And all solutions have two parts. Okay, so within the solution, there is a part that is dissolved and a part that does the dissolving. We call those the solute and the solvent. Solute is the substance being dissolved. So for example, if I wanted to make some iced tea and I had iced tea powder, that would be the solute because that's what I was going to be dissolved in. The solvent is what dissolves the solute. Okay, so if you again were making iced tea, you would put your solute in the solvent water, which would then dissolve it. And you would end up with the solution called iced tea. Or this could be Kool-Aid powder, water, and Kool-Aid, or salt and water and salt water. We're going to talk about the other types of solutions, but we are going to focus on aqueous solutions, meaning we have a solid dissolved in a solvent to form our solution. So for you to be able to remember what's what, the solute is always going to be the solid, the solvent is always going to be the liquid. Okay, so we did mention this type of solution called an aqueous solution. Aqueous solutions have a liquid state of matter. Okay, so they appear to be liquids. Usually involve a solid dissolved in some type of liquid, but it could be two liquids mixed together, like rubbing alcohol and water. Okay, they could mix. But there's a couple of examples. Saltwater cooling are some examples of aqueous solutions. It is possible to have a solution of gases where you have different gases mixed together. Air is an example of a gaseous solution. So it is a mixture, a homogeneous mixture. And solid solutions have a state of matter of solid, and that usually involves mixing or melting together different metals. So when we made our copper pennies or our pennies, we took copper and made a solution with the zinc and formed brass. So just recognize that there are other types of solutions, but again, we're going to focus on those aqueous or liquid solutions. Okay, now we're going to talk about some terminology related to solutions. What do you think we mean by concentration, and not in terms of thinking? If I were talking about the concentration of a solution, what do you think I mean? Can you put that into words? The what? How much citrus? Well, it depends on what your solution is, but how much of something? What would I be talking about if I were talking about the concentration of the solution?
It's concentrated.
Yeah, but what's concentrated? What does that mean, Brant? The what? And density, you could think of density. What would affect density? Not pH.
You were wrong, Lars. No, that's what I would say.
What would change the density of something? Added. Okay, so concentration has to do with how much solute, how much of your solid there is within your solution. So concentration, the definition is the amount of solute or the amount of solid dissolved in your solvent. So if you have a lot of solute dissolved, you're going to have a different concentration than if you have just a little bit of solute. Thank you. Okay, we throw in this at a given temperature, just because temperature can change things. We'll refer to that in a little bit. Yeah, but that doesn't have to do with concentration per se. It can affect the concentration, but so think about when you make yourself a glass of Gatorade. Okay, how many of you actually take the time to read the container if you have powder, figure out exactly how much you need, and put it in your drink? Or do you just kind of keep adding until it tastes good? That's what I do. I'm like, we'll just put some in, drink it. Nah, that's not good. We'll put some more in. Okay, what you're doing when you add more powder is you are changing the concentration. Okay, so when you first put a little bit of powder in or a little bit of solute, you have a dilute or a diluted concentration. Okay, so diluted means you have a low amount of solute, and it usually doesn't taste very good. Okay, so you put a little bit in, you stir it up, you taste it, you say, ugh, that doesn't taste very good. I'm going to put some more powder in. And by adding more powder, you are making it more concentrated. Okay, so when something is concentrated, it has a higher amount of solute in it. When you buy orange juice, or when your parents buy orange juice, you can get orange juice in liquid form in two different ways. Some of the containers say from concentrate, and others say not from concentrate. What do you think that means? Actually, it doesn't have anything to do with the pulp. Pulp is a separate thing. Rosie? It's not a flavoring, but it has to do with how it's prepared. They both will have the same amount of oranges, but the difference is something that is from concentrate implies that they took a very, very concentrated amount of the substance. So perhaps out in the groves, they picked the oranges, they squeezed them, and then they chemically processed it down to a small, very strong amount of orange juice. And then when they got them to the factory for packaging, they basically re-added water, diluted it into a big container, and that is from concentrate. Not from concentrate implies that it was fresh squeezed, they put it right in the container, and you're drinking it the way it came off the trees. Okay, so not from concentrate is a much fresher, unchemically processed way to buy your orange juice. So the next time your parents buy orange juice, tell them you want not from concentrate. And they'll be like, are you paying for it? You say no, and they say, then you're going to get it from concentrate. Okay, so it is more expensive to get it not from concentrate. Just a little side note there. So next time you're at the grocery store, if you ever go, it would be really strong. And your frozen orange juice that you can get frozen, that is concentrated orange juice, and you add water to it to make it less concentrated. Okay, so that's just two terms related to concentration. Okay, so here's pictures in case you like pictures. The yellow dots are the solute, the blue dots are the solvent. So if I put a little bit of solute in solvent, it's going to be dilute. And if I put a lot of solute in, it's going to be concentrated. Okay. The next three terms I'm going to show you visually. Okay, again, this deals with concentration, but it's some terms that they refer to. Unsaturated. Okay, all of this refers to the amount of solute. An unsaturated solution has less than the maximum concentration or maximum amount of solute dissolved. So for example, if I have some plain water and I want to make a salt water solution, and I add a little bit of salt, and I stir it up, if all of the salt dissolves, so if all of the solute is able to dissolve, and it is, it's just cloudy because I have bubbles in here now, meaning there's no solid on the bottom. Okay, all that salt I added is dissolved. This is called unsaturated, meaning if I wanted to at this point, I could put more salt in and stir and it would dissolve. So something that is unsaturated or not saturated means it is not full of all the solute it can hold. Saturated is the point at which you can't dissolve any more solute. So I'm going to add a bunch more salt. I could stir these until the cows came home, and I would never be able to dissolve all the salt because this water, this solvent, cannot possibly hold any more salt than it's already holding. So if I let this, can't really see it because it's still cloudy, but there is solid salt on the bottom there. Okay, so this solution right now is saturated. And I know that because there is leftover solute on the bottom. It is holding as much as it can possibly hold. So that is what saturated means. Other than adding more liquid, because if I added more liquid, I'd be able to dissolve some more salt. Is there another way I could get the salt to dissolve? Very good. If we change the heat and add heat to the solution, we can actually cause it to become supersaturated, which means that we will force this salt to dissolve in the water, because when you increase the temperature, it will actually allow more to dissolve. So I'm not going to heat it right now because I don't have anything to heat it, but it would eventually dissolve. So in order to supersaturate something, you have to increase the temperature to get more solute to dissolve. The reason people supersaturate things is to get more flavor, especially in the food industry. How many of you like the McDonald's iced sweet tea? Anyone? Has anyone had their sweet tea? No. All right, we have to go try their sweet tea. I like it, but most people find it terribly disgusting. So if you don't know the story of true sweet tea is not iced tea. Okay, iced tea means you take a glass of water, you put tea in it, and then you add sugar while it's cold, you stir it up and you drink it. Okay, but sweet tea is made hot. So what they'll do is they'll dump a ton of sugar in iced tea and then they'll boil it. That boiling allows all that extra sugar to dissolve, and then they cool it really fast, like they'll put it in a refrigerator, and the sugar stays in solution, meaning it doesn't become a solid again. So it becomes super, super sweet. You would never, ever be able to do that without heating it. So that is why sweet tea is so much sweeter than what you could simply make by adding sugar at a table. Okay, so that is a super saturated solution. So go have some McDonald's sweet tea. It's only $1. I don't work for McDonald's, I promise. I put pictures here again, but these don't make as much sense. Super saturated means it has extra solute, just the right amount, and not completely full. Okay, so we've heard the word solubility before, because back in our chapter where we were talking about states of matter and predicting the states of our our products, we talked about solubility rules. And in our solubility rules, we talked about things that were soluble versus insoluble. Things that are soluble do what? Dissolve. Things that are insoluble do what? Don't dissolve. Okay. So solubility refers to something dissolving. And what is being dissolved in a solution? Josh? The solute, did you say? Yes. So the solute is the thing that is being dissolved. So we refer to the amount of solute that dissolves in a certain amount of solvent. So I could determine the solubility of salt by figuring out exactly how much salt I could dissolve in this water at a specific temperature until I couldn't dissolve anymore. So don't, really get stuck on the definition here. Just realize that solubility talks about how much something can dissolve. Okay. All right, so there are different things that can affect how well a solid dissolves. Okay, so there are three main factors. First of all, shaking or mixing. So when I first poured the salt in here, I could have sat here for a very long time and it probably would have eventually dissolved, but not real quickly. So what did I do? I stirred it. Okay, stirring, shaking, mixing, those will increase how quickly your substance will dissolve. Temperature speeds up dissolving. Okay, so if you increase the temperature, it's going to dissolve faster. If you decrease the temperature, it dissolves slower. And the last thing that can affect how easily or quickly something dissolves is the size of the particle. If I put a sugar cube in versus granular sugar, which is the little pieces, which one do you think is going to dissolve faster? The little teeny tiny pieces. Okay, so smaller particles dissolve faster. It has to do with surface area to volume ratio, the same reason why cells are small. Okay, it has to do with how much surface area is to get dissolved per unit of volume. Okay, so just know little pieces get dissolved faster than big pieces. Simply adding more solute. So if I added more salt to this, is it going to make it dissolve faster? No. Okay, so adding more solute doesn't change how fast or how well it dissolves, but those other three things do. Okay, so